Welcome, my dear learners. Today we are looking at limits and we are looking at evaluating limits algebraically. Before we start, let's look at some of the properties of limits. So these are the properties and let's go through it. So let f at x as s approaches a and the limit of g at s approaches a of the function g at x exists and c be any constant, then we can say that the limit of the constant is equal to what? The constant. An example is the limit of 4 as s approaches 1 is equal to 4. So you can say that the limit of a constant is equal to what? The constant. Now the property 2 is also saying that the limit of a constant times a function is equal to the constant times the limit of the function. So when you have the limit of 4s squared as s approaches 1, we are saying that the constant should come out. So we are going to get 4 times the limit of what? The function, and s squared is the function. Now we have the third one. The limit of sum and difference is equal to the limit of sum and difference is equal to sum and difference of the limit. So when you have the limit of 4x as s approaches 1 plus 6s squared. Now this property is telling us that we just have to apply the limit on each of the functions, and then after that we apply the appropriate sign. So this is how we apply it. Now we have the limit of a quotient is equal to the quotient of the limit. We just have to apply the limit on each of the functions, and then after that we apply the appropriate sign, that is the division. Now the fifth one is saying that the limit of a linear function x as s approaches a is equal to what? A. And as the limit of a linear function as s approaches a is equal to the value x is approaching. An example is the limit of x as s approaches 4 is equal to 4. So the limit is equal to the value x is approaching, and we know that x is approaching 4, and that is the limit. Now the sixth one is saying the limit of x exponent n as x approaches a is equal to the value x is approaching raised to the index given. So when you have the limit of x exponent 2 as x approaches 2 becomes 2 exponent 2. And then the last one that we are looking at is the limit of a radical function is equal to the radical function of the limit. So when you have the limit of the function cube root of 4s squared plus 2 as s approaches 2, we are going to allow the limit be within the radical sign. We simplify to find our limit, and then we apply the index or the radical. Now that we know the properties, let's see how best we can apply these properties in evaluating the limit of a function algebraically. So we have the first example. We have to compute the limit of the following functions. So we are looking at polynomial function first, and then after that we look at a rational function. So we have the limit of the function this as s approaches -2. So in applying the properties, we are going to get the limit as s approaches -2 of 3s squared plus the limit as s approaches -2 of 5x minus the limit as s approaches -2 of 9. And this is what? Property 3. Which is this one. The limit of sum and difference is equal to sum and difference of the limit. Now, you can also apply the next property which is what? The limit of a constant times a function is equal to a constant times a function. So we are getting this, we are getting 3 out. The limit as s approaches -2 of s squared plus 5 out. The limit as s approaches -2 of x minus the limit as s approaches -2 of 9. So this property is property 2. So let's write it here, property 2. From here, we can also apply this property, the limit as x approaches -2 of x all squared plus 5 times the limit as s approaches -2 of x minus the limit as s approaches -2 of 9. Now from here, we can just take the limit. So we are having our 3 out. The limit of a linear function is equal to the value s is approaching, and that is this very property. So we are getting bracket -2 all squared plus 5 bracket -2 minus the limit of a constant is equal to what? The constant from property 1. So we are having -9. So when you simplify, we are going to get 12 minus 10 minus 9, and this is giving us what? -7. So this is the limit. Now let's take the next example. So example 2, we have to find the limit of this function as s approaches 1. So in applying the limits, applying the properties of limits, we are going to get the limit as s approaches 1 of 4 plus the limit as s approaches 1 of 3s squared minus the limit as s approaches 1 of 1, and this is property 3, P3. Now you can further also apply the next property. So you have the limit as s approaches 1 of x raised to the power 4 plus 3 out. The limit as s approaches 1 of x all squared minus the limit as s approaches 1 of 1. Property 2. Now from here, we can just take the limit and then we go away. So the limit of a linear function x is equal to the value x is approaching. So we are going to get 1 exponent 4 plus 3. This is also giving us 1 exponent 2 minus the limit of a constant is equal to the constant. So we have 1. So we are getting 1 plus 3 minus 1, and this is giving us what? 3, and that is the limit of this function. Let's take the next example. So we have the last example. We are to compute for the limit of this function as s approaches 2. So in applying the property, we are going to apply property 3 and then property 7. So we are going to get property 7 is saying that we first have to compute the limit and then we take the index. So we are going to get the limit as s approaches 2 of 5x power 4 minus the limit as s approaches 2 of 5x squared plus the limit as s approaches 2 of 2x. That is property 3 and then 7. So we have P3 and P7. So the next one, we are still going to apply the property. This is the cube root. So we have cube root of limit of a constant times a function. So we have 5 out. The limit as s approaches 2 of x power 4 minus 5 out. The limit as s approaches 2 of x all squared plus 2 times the limit as s approaches 2 of x. So from here we can take the limit. We are going to get 5 and then 2 exponent 4 minus 5, 2 exponent 2 plus 2 out and then 2. So we have 2 exponent 4 times 5 will give you 80 minus 2 times 2, 4 times 5, we have 20. 20 plus 4. So we have 80 minus 20 plus 4 will give us what? 64. And then the cube root of 64 will give you what? 4. And that is the limit of the function. We are done for today. In our next lesson, we are going to look at the limit of a rational function. Bye.